You're probably wondering what's that thing on the screen. Yeah, this. It's just a drop of water on top of the white screen of my mobile phone. Looks cool, right? But what's happening here? So, the drop of water is basically acting like a magnifying glass here to show you the contents of the screen. But I just told you it was a white screen. So, how do we see these three different colors? This can only mean one thing. The color white is actually made up of these three different colors: red, green, and blue. Okay, just to be sure, let's try mixing them up. That does not look like white. Looks somewhat like black instead. What's happening here? Well, this is happening because we are actually looking at two different color models: the subtractive color model and the additive color model. The first case that we saw was of additive color model. Here we were mixing colored lights instead of physical paints. And when we mixed colored lights, their wavelengths get added instead of getting subtracted. So the resultant color here has a wavelength equal to the sum of the wavelength of the two colors mixed. So when we add the wavelengths of all the three different colors, red, blue, and green, we finally get the color white. This is basically how all different digital screens work. They have tiny units which can only flash three different colors: red, blue, and green. And different amounts of these three in combination gives you all different colors on screen. So if you see a yellow on screen, it's basically two colors, red and green, being flashed together. Similarly, for magenta, it will be red and blue being flashed together. So the next time you're staring at a white screen, remember, this is what you're looking at. Now, if we zoom out a little, now you can almost see how they are making up the color white. Then comes in the subtractive color model. It's actually fairly easier for us to understand the subtractive color model because we are so much used to it. As kids, we used to mix a lot of paints, a few still do, and mixing of physical paints follow the subtractive color model. Here, when we are mixing two different colors, the wavelength of one color is being subtracted from the wavelength of the second color to give you the resultant third color. So when we are mixing two different paints, say blue and yellow, the wavelength of the color blue is being subtracted from the wavelength of the color yellow to give you the color green. That, however, is not the case when we mix blue and yellow colored lights. We get the resultant color as white when we do this, because the wavelength of the two colors are getting added here instead of getting subtracted. So in a subtractive model, if we are mixing in all visible colors, we are basically subtracting the wavelength of all colors till we are left with no wavelength at all, which means there's no color at all. So we are basically left with black. Okay, so now we know why this was happening. So now if we look at these two different color models, in additive system, we basically have three primary colors. We just mix these three colors in different intensities and amounts to bring in all the other different colors. So these primaries here for the additive system are red, green, and blue. On the other hand, if we look at the subtractive model, here the primaries are cyan, magenta, and yellow. So we just mix in these colors to get all the different colors. In both the models, secondary colors are the colors which we get when we start mixing the primaries. Now here's an interesting observation. The primary colors of the additive system are red, green, and blue. Now, if we mix red and green, we get the color yellow. We mix the colors green and blue to get the color cyan. And we mix blue and red to get the color magenta. And we know what these three colors are. They are the primaries of the subtractive model. Now, if we mix the primaries of the subtractive model, which are cyan, magenta, and yellow, we basically get the primaries of the additive model, which are red, green, and blue. So the primaries of the additive are the secondaries of the subtractive and vice versa. Now, if there's still any confusion in the way we are mixing colors in these two different color models, I have a better way to explain. Hold on. Let's just consider these two colors, black and white. We'll just assign a few values to them, which will be corresponding to their wavelengths. The color black technically has no wavelength at all, so we are just assigning the value 0 to black. On the other hand, the color white has the maximum possible wavelength, so we are just assigning an arbitrary value which is equal to 10. Now let's also assign some values to the color red, green and blue corresponding to their wavelengths. Again, red has the highest wavelength, green has a wavelength which is lesser than red, and blue has the least wavelength. So we've just assigned the values 5, 3, 2 to red, green and blue. Now talking about the subtractive color model, here we are mixing different paints and the wavelengths are subtracted. So if you're mixing the colors red, green and blue, the wavelength of green and blue will be subtracted from the wavelength of red and we are left with the value 0, which gives us the color black. Whereas in the additive color model, instead of mixing paints, we are basically mixing colored lights. So the values are added, and if we mix green, red, and blue, we are left with the value 10, which corresponds to the color white. All digital screens hence work on the additive model and use three channels red, green, and blue to show you all the different colors on screen. So basically, any digital screen that emits light, like mobile phones, tablets, laptops, and televisions, will be using this model. On the other hand, wherever print media is involved, we get to see the subtractive color model. So basically, it works on four channels: cyan, magenta, yellow, and key. I know I didn't talk about key, but key basically is the color black. If you mix cyan, magenta, and yellow, you get a dark color, but again, it's not dark enough. So to fill that gap, we generally use pure black as a color in print media. So that's known as key. So different amounts of these four channels are used to show you all different colors on magazines, posters, and every other printed media. You get to see the same setup in the cartridges of a printer as well. Well, that will be all for today's video. If you have any doubts, let me know in the comment section. Till then, stay safe, have fun, and keep mixing.